As described by Adams et al. 2010, central tendencies are numbers that describe what is average or typical of the distribution. So these include establishing the mean, median, and mode of a dataset, whereas the variability of data shows the dispersion of data. So these include establishing the range, the interquartile range, and the standard deviation of a set of data. The mean is the average value of the dataset. You calculate the mean by adding up all the scores, then dividing that number by how many values there were. So shown in figure 20, in the example above, is the mean value of this dataset. So the sum of all of the values was 421, and because there were 14 values, you divide 421 by 14, which equals 30.1. So that is the mean of this set of data. The positive aspects of the mean is that it takes all of the data into account when doing the calculation, and it works closely with the standard deviation and can influence the standard deviation. It is important for a researcher to know about how spread out the data is, and they can't do that without establishing the mean first. However, the limitations to the mean are that it can't be used for nominal and ordinal data. It's heavily influenced by outliers, and sometimes the average isn't realistic in terms of reality. For instance, the mean of the people in a data set could be 2.5 people, and that isn't really an average, as you can't have 2.5 people. Next is the median. When the data is in rank order, the median is the middle value. However, if there is an even number of values, then you find the position of the median by adding 1 to the number of values there are, then dividing that number by 2, and that will give you the position of the median. So in figure 21, the number of values in the set of data are 14. Therefore, to find the median, we need to find the position. So you add 1 to 14, which gives you 15, and you divide it by 2, which is 7.5. So the 7th and 8th position added together, then divided by 2, equals 30. So the median is 30. The benefits of this is that the median is less influenced by outliers, as it is the position of the middle value, not the actual middle number in the dataset. The median is best used with ordinal data, so rank-ordered data. The limitations of the median is that the median might not represent the whole dataset, as the median is not about the content of the numbers, just the placement of where the numbers are when they are rank-ordered. Also, it's slow to calculate the median manually with a large set of data. The mode is the most frequent value in a set of data. It is the value that occurs the most. And as you can see in the table above, circled in red is 32. 32 in this data is the most common value, as it appears the most times. The benefits of the mode is that the mode can be determined for nominal data, as you can clearly see in the categorical data which value or score occurs the most, whereas you can't use the mean or median for nominal data, as the data is split into categories. The mode can easily be seen from a frequency graph. The limitations within mode is that it doesn't include the whole of the data set. This is a limitation because it doesn't take into account the whole of the data. Therefore, the researcher only then discovers one aspect about their data, so one value. Also, there can be more than one mode. You can have a bimodal data set. This means that more than one result can be frequent, which is a problem, as having two modes in a data set obviously doesn't mean that one value was more frequent than the rest.